Okay, so this device is called a Graff Generator, and the main feature of this is basically this polymer belt here, which doesn't conduct electricity. What it can do is, when it comes in contact with different materials, it can drag electrons from one material to another just because of the contact of the belt. So what actually happens in this apparatus is we have a motor in the bottom of this unit which drives this belt over a dissimilar material in the top here that's attached to this metal dome. That actually drags electrons out of this dome, leaving it with quite a high net positive charge, down to a comb at the bottom here, where those electrons are stripped away off the belt and come up this second electrode, this electrode here. So basically there's an electron flow down through the belt. Well, the belt drags electrons away from this dome here, and they're allowed to flow back up this line here to this second sphere. So what happens when I turn this on is basically I'm going to create a huge potential difference between the charge on these two spheres. So this will have a very low positive charge. This will have a very high positive charge, and this will have a high negative charge. So what we've got is a very big electric field in the space between these spheres, and so what happens as this charge builds is quite interesting. So let me just turn on the device here. So basically I've got two adjustments that I can make here. I can adjust the speed that the belt is travelling around the rollers. So this is in effect the number of electrons that are being dragged from this sphere here in a certain amount of time. And I can also change the distance between the two electrodes. So basically what happens is as the charge builds up on the sphere here, we get a very big potential difference between the large and the small sphere. That builds to a certain amount, and then that charge wants to go somewhere. There needs to be an electric flow from the negative to the positive side of this circuit. So that happens by an arc, just like lightning or sparks on a circuit. Because the potential difference is so high, the electrons literally jump across the gap. So basically you can see here, if you look closely, we've got quite a significant spark going on between these two spheres. You can actually see there's some quite significant force involved with this loss of charge as well, because the second electrode is actually moving backwards and forwards with each charge on the circuit. So we can increase the amount of charge going onto the sphere per second by changing the speed. So if we increase the speed, we're increasing the rate of the sparks, and I can also move it further away. And basically we can increase the energy in each spark because more charge is building up between each spark crossing the gap. So in effect, it's just controlling the number of electrons and the disproportionality between the positive and negative charge is in the system. But the interesting thing here is, even though this is many kilovolts in voltage, which you would think would be quite harmful, I can actually put my finger in here if I want. I'll just get a nasty spark. But it's not going to harm me. Basically, even though there's thousands of volts in this system, it's actually not harmful to me because of a very small amount of charge that's actually involved. Because when we convert that charge into current, it's a very, very low amount of current that's actually passing through my body if I put my finger in this system. So it hurts a little bit, but it's not really posing a threat or a danger to me. Even though we can see there's quite a considerable amount of energy causing these sparks in this system. So luckily, I'm not at danger in this particular circumstance. Okay, so let's discuss why that is.